Welcome to the next lecture of the numerical integration. In today's lesson, we will talk about one more formula to achieve the numerical integration, and that is Simpson's 3 by 8 rule. In the previous lesson, we had seen Simpson's 1 by 3rd rule. So let's see how we can derive Simpson's 3 by 8 rule first, and then we'll see an example and solve the numerical integration with the help of this Simpson's 3 by 8 rule. As in the previous lessons, to derive the trapezoidal and the Simpson's 1 by 3 rule, we have used the Newton's-Cotes quadrature formula. In this also, we will be using the Newton-Cotes quadrature formula. So this is the Newton-Cotes quadrature formula. We will be using this. In this Simpson's 3 by 8, we have this formula is for n is equal to 3. That means the elements that will be considered till the power of 3 and higher degree terms will be ignored here in this case. So let's see, and we can take the intervals with the interval, we can take the lower and upper limit with the interval 3. As we have already seen that this can be integral can be written as the sum of smaller sub intervals. So let's see if this interval x0 to xn fx dx can be written as x0 to x0 plus 3h. Yes, we are taking here 3h because n is equal to 3. Fx dx plus the next interval will begin from x0 plus 3h till x0 plus 6h fx dx plus x0 plus 6h x0 plus 9h fx dx plus and so on till x0 plus n minus 3h, and this is x0 plus nh fx dx. So this large integral can be written as the sum of these smaller sub-integrals, and now we will evaluate these smaller sub-integrals with the help of the Newton-Cotes quadrature formula. So let's first derive this x0 to x0 plus 3h. For that, we will keep n is equal to 3 in the formula. So now this will be x0 to x0 to x3, let's say x0 to x3 or x0 to x0 plus 3h. This is fx dx as n is equal to 3 here, so this will be 3h y0 plus 3 by 2 del y0 plus 3 to the 6 minus 3. So this is 6 minus 3 will be a 3 upon 12. So this is 3 upon 12 within the brackets del 2 y0 plus 3 minus 2, that is 1 square is equal to 1. So this is 1 upon 24 del 3 y0, and we will ignore the higher degree term because this is the formula for n is equal to 3. So we will consider terms only till the order 3. Now on solving this, as we can see that this is a 3, we can cross it 3. So this will be 3 upon 4, and this will be, let's say this is 1 upon 8. We can take 8 as an LCM and keep it outside. So this will be 3 upon 8h. As we can see, the common term comes to be 3 upon 8 as the rule's name suggests. This is Simpson's 3 by 8 rule. So 3 upon 8 is in the common term. Now we have 8 y0. So this is 3 upon 2 plus 4 3s are 12 del y0 plus 2 3s are 6 del 2 y0. I have taken this 8 in the LCM, and plus this will be del 3 y0. Putting the values of this del y0, del 2y0 and del 3y0 into the formula, this becomes 3 upon 8 h 8y0 plus 12 of del y0 is always y1 minus y0. So this is 12 y1 minus 12 y0 plus 6 del 2 y0. The del 2 y0 is always y2 minus 2y1 plus y0. So I need to multiply the 6 inside. So let me do it. This will be 6y2 minus 6 2s are 12y1, and the last one is plus 6y0. Del 3. The formula for the del 3 is y3 minus 3y2 plus 3y1, and this is minus y0. So we have opened this. On solving this, we can see this is 8y0 minus 12y0 plus 6y0, and this is minus y0. So 8 minus 12, this is minus of 4, minus 4 and plus 6, this is 2y0, and minus y0, this is y0. So we have, let me write it here up on this place. I want to remove this. So now let me solve and write this here. So this is 3 by 8h, and we have seen that this is y0. Now let's calculate y1. So this is 12y1. This is also 12y1, plus and minus cancelled out, and we are left with 3y1. So this is plus 3y1. Let's see y2. So we have 6y2, then we have minus 3y2. That's it. So this will be plus 3y2. y3, let's see. Okay, we have y3. This is 1y3, so this is coming plus y3. So this is the formula for x0 to x3 fx dx, or we can see x0 to x0 plus 3. This is the solution for the first subinterval. In the similar way, we can write the solution of the further subintervals. Let me write the solution of this second subinterval. This will be x3 to x6 fx dx. Now this will be 3 upon 8h y3 plus 3y4 plus 3y5 plus y6. Right, so we have jumped from x0 to x3. So in place of y0, this will be y3. In place of y1, this will be y4. This will be, and you can see the upper limit is x6. We have jumped from x3 to x6. That means y3 will be converted to y6 the same way. So we'll move forward this 3 places. Now let's write this last one. As we can see, x0 plus n minus 3h and x0 plus nh. That means the x3 will be replaced by n minus 3. So everywhere we have this y3, we'll have y of n minus 3. Let me write it here. So now this is x of n minus 3 to xn fx dx. This will be equal to 3 upon 8h. Within the bracket, this is y3. So here we have a lower term xn minus 3, that is y of n minus 3 plus y, this is thrice. So this is 3 y of n minus 2 plus 3 y of n minus 1 and plus yn. So this is the last subinterval. And as we know that we can achieve the final integral by summing all these. So we need to sum all these. So let me write the sum on top here. I am removing this. So the left hand side will be the final integral from x0 to xn, and on the right hand side we want to sum all these. As we can see, the common term in all the subintervals will be 3 upon 8h, 3 upon 8h in all the subintervals. So we'll take this common, 3 upon 8h inside the brackets. Now we can see y0 in all the formulas will come just once. So let me keep it y0, and the last one yn will come once. So this is y0 plus yn plus. And now you can see 3y1, 3y4, 3y2, 3y5, 3yn minus 2 and 3yn minus 1. So we have a group of thrice. So let me write 3, and inside that I'll have a y1 plus y2 plus y4 plus y5 plus next term would have been y6 will not be here, so that will be y7 and y8, where y9 will not be here, y10 and y11 and so on. And in the last we can see that this is yn minus 2 plus yn minus 1. So this will move from y1 to yn minus 1 with some missing terms. So this is all the groups of 3. We have one more group. We can see this is y3 coming twice. Similarly, y6 and y6 will come twice. Similarly, yn minus 3 and yn minus 3 will come twice. So this is the group of twice, in which we have y3, y6, we'll have y9, y12, y15 and so on till y of n minus 3. So this is the formula for the Simpson's 3 by 8 rule. Now let's solve one example using this Simpson's 3 by 8 rule. See, this is Simpson's 3 by 8 rule, and we need to solve this integral. We have to find the integral of integral 0 to 6 1 upon 1 plus x square dx with the help of Simpson's 3 by 8 rule. First decision, number of intervals. As you know, here the number of intervals has to be the multiple of 3. So in this case we can have 3 intervals, or we can have 6 intervals. Let's say if we are making 2 intervals, that will be right? No, that will be wrong, because 2 is not the multiple of 3. Let's say if we are making 5 intervals, will that be right? No, because 5 is not the multiple of 3. Let's say, like in the previous case, in Simpsons we could have made 4 intervals. That was right for Simpsons 1 by 3. But can we make 4 intervals here in this case? No, because 4 is not the multiple of 3. So we can make 3 intervals, we can make 6 intervals, we can make 9 intervals and so on. So let's make 6 intervals here in this case. So once we make 6 intervals, our data table would be something like this. So we'll have the values of x and respective y. Y is the f of x, the function, that is 1 upon 1 plus x square. So now, just to make 6 intervals, we'll start with 0. So this will be 0, then 1, 2, 3, 4, 5, and lastly this will be 6. Now let's find out the values of y, that is this function fx 1 upon 1 plus x square. So just to get this at x at 0, this will be 1 upon 1 plus 0 square, which is 1 upon 1, that is 1. So we have 1. At 1, so this is 1 upon 1 plus 1 square, this is 1 upon 2, which is 0.5. So we'll have 0.5. Add 2, 1 upon 1 plus 2 square, this is 1 upon 5, which is 0.2. So in the same way we can complete this table. So now these values will be y0, this will be y1, y2, y3, y4, y5, and this is y6. We'll be using Simpson's 3 by 8 rule and substitute all the values. What is the value of h here? H is 1. The difference between two values of x, 0 to 1, it's 1. 1 to 2, it's 1. 2 to 3, it's 1. So the difference between any two adjacent values of x, that is h. So now this is 0 to 6, 1 upon 1 plus x square dx by Simpson's rule will be 3 upon 8 h. What is the value of h? As I have already told you, this is 1. Now inside y0 plus yn. What is y0? y0 is 1 plus yn, the last value in the table. This is y6, so this is 0.027 plus thrice of y1, y2, y4, y5, y1, y2, y4, y5. So we have these values y1, y2, y4 and y5. Now what is y1? y1 is 0.5. What is y2? 0.2. What is y4? y4 is 0.0588. 0.0588. What is y5? y5 here is 0.0385 plus this is twice of y3, y6 and so on. So we have only y3 here. We will not consider y6 because y6 is the last value into this and this is yn. So we will not consider y6. We will only consider y3. So what is the value of y3 here? y3 is 0.1. So this is 0.1. Now we need to calculate all this, and on calculating this is coming 1.35708. So this is 1.35708. This is the final result of this given integral with the help of Simpson's 3/8 rule. I hope you have understood the formula and the example. If you have any queries, feel free to comment your queries in the comment box. Thank you so much.